so because we did not meet last week, we've got to do a quick hurry up on finishing chapter 2 and then introducing chapter 3, because we've got to try to catch up and get back on schedule. Okay, so the first question that I was asked was whether or not we can look at section 2.2. Well, it just so happens, you can't see it, but I had already planned to do section 2.2. All right, now, vocabulary. Vocabulary. All right, very important vocabulary, domain and range. Okay, you must understand what each is. Okay, that's the first thing. Now, what is domain?
Yes.
Values of x. Now, it's the independent variable. That means it's on the horizontal axis. Okay? Now, the range are the values of y, usually, right? And it's the dependent variable, so it is on the vertical axis, the up and down axis. Okay? Now, the part that becomes important for discussing things is the vocabulary of this right here. Okay? Now, this is very important, so I'd like you to write this down in your notes. Alright, I want you to copy both of these down, and then we're going to put a few words that describe how you're supposed to interpret what this says. Alright, so you're going to write D equals the set, alright, of x's such that, alright, what does D stand for? Domain. Domain is equal to the set of x's such that, and then what comes after is the equation. In this case, the inequality. And then this one, R for range. Range is equal to, range is the set of y's such that. This is not the set of x's such that. Set of x's such that. That's the vocabulary. You need to write that into your notes, because those are the words that describe this first part. All right? And so when the teacher begins to interpret this, right, you also need to know why those things are written there. Now that makes this scary looking thing be a whole lot less scary. Right? And therefore this part is, because this is a dual inequality, it's read from the center. Okay? Now, what does the center say in this top one? The center says x is smaller than 7, x is greater than -4. Okay? Y is greater than -8, y is less than 11. All right? And even if these signs are switched, if you read it from the center, what I do is, if the big end is pointing toward the x, x is bigger. If the small end is pointing to the x, x is less. See that? So you can read it from either direction. Right? And later on, when we want to flip this, if I want to say x is greater than, right, what I'm going to have to do is write x, let me see if I can make this thick enough, x is greater than -4. X is bigger than -4, x is bigger than -4. Okay? And if you consider these dual inequalities just reading from the center in both directions, then you're not going to make the mistake of having the sign incorrect if you have to flip it around. Okay, does that make sense? Questions on that? Okay. Yes? All right, go ahead. you understand what we just did here? Okay, this is the definition of what this thing looks like. Okay, so if you see domain is the set of x's such that x is greater than -4. Well, on a number line, where's that located? On a number line, wherever -4 is, the greater than part is over here. And because there's no equal sign, I'm going to put a circle on there. Right? And then this part says x is less than 7. That means I'm going to go over here to wherever 7 is. Right? And it's going to be an open circle because there's no equal sign here. Right? Had there been a line underneath it, I'd color this in. Right? And then if it's greater than this and less than this, then it's in between. So I'm going to just make that darker. All right? And so this becomes the graph of the domain. Now, that means that wherever the y for the range is, I'm only talking about the area that's in between here because the domain tells me where I start. The range tells me where I end up. Now, what does the range say? That y is greater than -8. Well, that's way down here. All right? And see, the axis is going to run about here because this is -4 and this is +7. And so -8 on the y is way down here. So that means I got to be above that, and 11, which is way up here, says y is less than 11, so that means I'm going to be in this area here. That's where my function is going to be located. Now, there's lots of different functions you can have. You can have straight line functions, you can have curvy functions, you can have relations because the x can go to two or more places. But if I do that, I have to start here. And then there. Okay? Now, is this a function? Is my first question. All right? Is this a function?
Yes.
No. Because I can have the same value of x in more than one place. Right? If it were a function, then the vertical line test would not hit here and here at the same time. Okay? All right, so this is a relation because of what the definition of a function is, but as far as the domain and the range are concerned, I can't go below this because of what it says about x. I can't go above this point because of what it says about y. All right? Now, what's inside here is can be any type of result depending on what the mathematics is. Now, you're going to be asked to just make one. Well, how hard was that to make? How hard was the red line to make? No. But what I had to do first is I had to know where my limits were. I had to know the limits of the domain, and I had to know the limits of the range, and then I just throw a point in between. Now, the easiest thing to do would have been to go down here and come up here and draw a straight line. Right? Because now I've used the limit of the domain and the range at the same point. Right? And the upper limit of the domain and the range at the same point. Okay, that's usually where the problem is what do I write for the function? Okay? Now, because this is a straight line, it is a function. All right? Question? Does that help? Okay. All right. Now, so let me erase this so that we can move to the next part. All right. That's not going to make it, is it? It's left-handed now. Oh, it's almost empty. That's the problem. Nothing's coming out. All right, so let's move on. Okay, now, next part. In section 2.3, you're asked to analyze some words and come up with a decent estimate of what the graph is supposed to look like. Okay? Now, because of all the words, this looks really scary. I mean, it does. When I first saw it, I thought, oh my gosh, what are they doing? Because I don't like to read either, right? But, okay, here's the two things that help. Time is usually independent, therefore it's on the x-axis. So whenever you see two things that are being compared in this section, you know, it's talking about the distance from the start is related to the time you've been traveling. Whenever you see time, you know that's going to be on the x-axis almost exclusively. And if time is on the x-axis, then distance has to be on the y, because that's the only place we have left for. Okay? Now, the same thing in reverse is true with cost. Cost is usually the dependent variable. It depends on how many things you bought, right? So the number of things you bought would be on the x, and then the cost is going to be dependent on that. It'll be on the y. Right? If you look at anything to do with dollars and you propose that it's a y variable, it's the y-axis, and anything to do with time, you propose that it's on the x, most of the time the graph itself will take care of itself. So now I've got an L, and I have time across the bottom, I've got cost or money on the side, and then the question is, where do you start? Does it start at 0? Or does it start at some number? And what's happening? Am I going down or am I going up? Am I going fast and straight, or am I going slow and a little curve? Right? And then the rest of it has to do with what the words are talking about. Now, if you don't know how those things actually operate in real life, then it's going to be pretty tough to know what the graph is going to do. Right? But you can always ask yourself, does this start at 0 or does it start at some other number? Okay, now, let me see if I can get right here. Okay, so if I make, oh man, it's not working.
There's another one next to you.
Yeah, I'm going to see. I think I'm not hitting it right. I'm trying to make it dark enough for the video to work. All right, I said here. All right, so I'm going to have time here, and I'm going to have something else over there. And just right. When I did these things, that's what I did. I wrote time there, and then whatever the other number was, I wrote there. Okay, now, if it starts at 0, that means I'm going to start down here, because this is the origin. Right? Now, the first question is it going straight or is it gradually getting larger? So if it's gradually getting larger, then this thing is going to curve a little bit. Now, that almost looks like a straight line, doesn't it? Right? But it doesn't have to be a straight unless it says that the change is constant. Right? A constant change means that it's a straight line. So if it's not specifically constant, then it goes like that. Now then the question is, when it keeps going, if x goes on forever, will the range keep increasing, or does the range stop at some particular point? If the one with the range, speaking of range, if the range is the range, the oven, right? Then eventually the temperature is going to level out at whatever you set the thermostat to, right? And so for time and temperature of the oven, eventually it's going to reach a point, and this is called the asymptote, the asymptote. The asymptote is the arbitrary line that the temperature of the oven approaches but never goes over. All right? And that's a vocabulary word that you're going to need for Algebra 2. All right? Now, if I were to take this range and I were to limit the domain, then this thing may not continue forever. Right? But provided that the oven stays on, this theoretically could go until I turn the oven off. All right? Okay, so almost all of these graphs are set up just like this. Now, the number that goes down here, the value of time could be seconds, could be minutes, could be hours. Right? But I'm not worried about that because this is all hypothetical or theoretical anyway. Right? But the question is, does this keep going or does it level off? This is the harder one because you have to understand that sometimes things level off. Now the same thing would be true if I were emptying something. If I'm going to empty something, then it starts full. And it goes down. Now, the one that I remember was that the amount of water left in the tub is related to the time since you pulled the plug. Right? So, I don't know, you guys never have taken a bath, have you? Most everybody takes a shower nowadays, right? You know, okay. And beside that, well, it's the first of the month, so you should have already had your shower for the month.
Yeah.
Right? Okay, so because the tub is fixed, the rate of the water going down should be relatively constant. So it's going to go like this. And eventually, where's it going to go? It's going to go until it reaches empty. And after that, technically, it goes like that. Right? Because as soon as the tub is empty, right? Like right now, the plug is pulled, right, in your bathtub, right? And so the hole is open. How much water is going through it? No, none. Right now, your bathtub is at none, right? And so as time continues, there's no more water going out. Now, what happens if you put the plug in? Nothing, because we haven't turned the water on yet. Okay. All right, that was trick. Okay, does that make sense? Okay, yeah, Sydney, does that help you? You see, and so now here's the other thing. I didn't say this, right? So this is not on the tape. But after we get out of chapter 2, that sort of thing we're not going to use hardly at all. The concept of it is important, but we're going to use different criterion for what the graph looks like. And that's the next thing I want to go to while we're talking about this, right? So don't stress too much. This type of information I gave you, remember cost, if you got it, it goes here, whatever else that you have will normally go here. Yes?
So the next chapter is going to be easier?
Yes, yes. Yes. Because this was so theoretical that it was hard to get a grasp of what is it they're asking. Okay, all right, so let's move to one other thing. All right, now this is for notes again. This is important for your notes. Y equals mx plus b. This is 1 and this is 1 as far as exponents. This is a line. That's called a linear equation. All right, you should already remember that from Algebra 1. Okay, if you have y equals x squared, you have a parabola, and it looks like a U. Okay, now, when the x is squared, the sign tells me which end the open is pointing to. So if I gave you y equals negative x squared, then the open end is going to point to the negative, so it's going to open down. Right now, because you're going to see this, so then what happens if I have x equals y squared? Instead of opening up and down, it's going to open left and right. Which way will this open? To the positive. So it's going to open like this. Now, this is a function. This is not a function. Because it doesn't pass the vertical line test. And so what would x equals negative y squared look like? It's going to open toward the negative. It's going to open like this. Okay? All right. Third thing. Y equals the absolute value of x. All right. Now, do you notice this is first power and first power? It ought to be a straight line. But the absolute value mark says stop at some point and go back positive. So it becomes a B. And then x equals the absolute value of y. What do we do with parabola when we change the x's and y's? We change the orientation from vertical to horizontal. The same thing is going to be true with this B. Now again, the positive opened up. So the positive points to the positive. Now, is this a function? No, it's only a relation. Okay? Now, in Georgia, all this information was part of the 7 different graphs that 8th graders had to know by sight. And the quiz I used to give is I would give this, and the student had to be able to draw the graph, had to draw this picture, the U, the V, the line. Right, because we're going to another set. Alright? What does y equals x to the third power? What's that look like? Ooh, you should know. Again, you should have known. You probably have been told. But what happens with this is that it starts when x is very negative, y is very negative. And it comes up like this, and it goes like that. That's Q. All right? X to the fourth power looks like a parabola, except inside it goes like this. All right? And I'm going to show you one other thing. Watch the slopes. Positive slope, negative slope, positive slope. 1, 2, 3 turns. X to the third.
Oh.
Negative slope, positive slope, negative slope, positive slope. 1, 2, 3, 4 turns. Alright? See, everybody thinks that the higher math students make this great leap of intelligence, and they can look at that graph and they can tell you what the x value or what the x exponent is of that graph, but that's all they did was look at how many turns it made. Okay? So it's not as mysterious once you get to start doing it. Okay? Alright, so those now the others that are here are things that you should know. If you do not know them by heart, you need to look at it and practice it until you can understand what that graph looks like. Because that's going to help you in the future. Alright? Okay, so I hope that we have covered those things. Alright? Now, so then the question would be, if I give you a graph that looks like this, and I start here. And I go to there. All right, what do you notice about the graph that I drew? All right, I tried to make it so that it is a function, right? Because I tried it not to pass the vertical line test, so that every value of x only goes to one place on the graph. Okay, that's the first thing. So this is a function. All right, what do you notice about the ends?
One's open, one's closed.
Say again?
One's open.
One's open and one's closed is what I was going for. All right, this is open and this is closed, right? So when I look at the values of the range in the domain, I'm going to have greater than or less than here, but I'm going to have greater than or less than and equal here. Okay? Now, so then the question is, how do I determine the domain? All right, again, domain is the set of x's such that, now, what do you know? Where's x? All right, does it equal 1? Okay, so that means I need an equal sign here, and I need 1 there. All right, why didn't I fill in the other part of the equal sign? Because it doesn't stop there, does it? Doesn't it continue from there? So that means it is greater than or equal. So x is greater than or equal to 1, and where does it end? 1, 2, 3, 4, 5. X is less than 5. All right? That's the vocabulary for talking about the domain of this. Now, tell me what you do for range. Okay? For range, I take the top, and now, is it equal to it there? Right? Technically, is this. Right? Technically, right? So that's a dot on the graph, but what about the lowest point? The lowest point's an open circle, right? So the range is equal to what?
The set of y's.
The set of y's such that, now, y has to be, you do it, I know how to do this. Whoa. Okay, all right, now notice, here's the bottom part. Y has to be greater than, right? So y has to be greater than, let's read that way, open circle. So I don't use the equal, greater than what? 1, all right? And y has to be less than or equal to 1, 2, 3, 4, 5. All right? And we have just determined the domain and the range of that graph. That's that section. Okay? Now, so what you're looking at is something that you could do this way. Those are my range values because they cross the y-axis. And those are my domain because they cross the x-axis. Right? And so I am greater than this, less than this. I am greater than this, and less than that. Okay? Yes?
You said this was section 4?
This was, I think this was 2-3.
Okay.
I think. I'm pretty sure. 2-3. Let's see. That's 2-4. I'm sorry. That's the 2-4 that you asked for. But 2-3 and 2-4 are related. 2.3 has to do with you drawing it, and 2.4 they give you one and they ask you to do the domain and range. And if I'm grading the paper, I want to see the domain and range written correctly, because you are smart people and you should be able to handle writing it correctly. Okay? And I think you're going to find that's the answers in the exercises we're given like this. All right, yes, question? All right, okay. All right, now, let's try to move into some new stuff if I can. Okay, all right, now, turn to page 70 real quick. Turn to page 70. Page 70, I want to look at the review question because you're going to have to do the test, and I want to show you some things that are important. Man, oh man, they're completely out. See, the part that got it turned it white again, didn't it? Okay, all right, now, if you'll notice, the problem A, I have changed its look. Instead of x plus y equals 2, I have taken the x value, subtracted it, and moved it to the other side, because this is the slope-intercept form that tells us how to graph it. Okay? Now, the domain was given, right? So, if the lowest point of the domain is x is greater than 1, when x is 1, what happens here? It becomes negative 1 plus 2. How much is that? It's 1. So, the range when x is 1 will have a value of y of 1. Now, at the top part, what happens when x is 3? What is negative 3 plus 2? Negative 1. So now I know what my range will be. My range will be, y will be less than negative 1, greater than 1, or greater than 1, less than negative 1. Right? But that's how you're going to figure that out. Okay? Now, same thing is true with this one. Right? I've taken the x squared and subtracted it so that I get y equals x squared. Now, the reason that I told you something about what x squared looks like, what is this going to look like? What's x squared mean? What's the graph look like? Looks like a what? A u, right? And if it says minus, the u is going to open toward the negative, so it's going to be upside down. Okay? Now, this is 5 distinct points. It is not continuous like this one is. So this is going to have 5 dots. Alright? How do you find the dot for the domain of 2? What is 2 squared? Come on. 2 squared. 4. Opposite of 4. Negative 4 plus 2. So I'm going to graph negative 2, negative 2. That's one of the points on the graph. And if I define it, the range will equal all the values of y such that the set has to start with negative 2. Now, put negative 1 in here. What's negative 1 squared? Negative 1 squared is 1, and then this makes it negative 1. 2 plus negative 1 is 1. So, negative 1, 1 is another point on the graph. All right, and you just work them that way. All of these work the same way. Okay. So why did I do square root here? Because one of the things that you look for is a square root function. Right? That's one of the ones that they used to do. A square root function looks like this. Right? And if you'll notice, that's half parabola. Because this half is usually imaginary.
Right.
Okay? Alright, and because this, again, so those values, but again, these are points, and so you're going to substitute. What happens when you substitute a 0 here? Square root of 2. And square root of 2 is just a point on the graph, somewhere between 1 and 2. Right? When this is a 1, you have the absolute value of 1. The square root of 1, which is 1. So 1, 1 is a point on the graph. And then the same thing will be true down here. This is continuous, but this is absolute value. So you know that absolute value is going to look like this for x and like this for y. So the absolute value is going to look like this one, except it's pointing negative, so it'll flip around. Negative. Okay. All right. So those are. That's R1. Now R2 on page 70, it's asking you to tell whether it's a function or not. Yes? Go. All right, in order for it to be a function, there can only be one y for every x. All right, and that a lot of times we use with the vertical line test. All right, if you look at problem number C, or letter C, if you take the vertical line straight through those two circles, it's only going to touch one place because one of the circles is open. So therefore that is a function. When you look at E, in between the two circles, you're going to hit it in two places. Right? You're going to hit the upper part and the lower part. So because the vertical line test hits two different places for that x, it is only a relation. It is not a function. Okay? Now, so then what does that do with f?
It's a function.
Why? Why would you say it's a function? Because in between the two circles, it does not hit the graph twice, does it? In fact, it doesn't hit it at all in between the two circles. Right? So it's a function that has a gap in it, but it doesn't, in between it doesn't hit the graph twice with the vertical line, so the last point is also a function. Although it's not a continuous function. Right? Okay? Alright, now, those pieces of information should get you ready to take the Chapter 2 test. Okay? And what we're going to do is that when I get the test back, I'm going to mark it, right or wrong, without comments, so that you can then do the corrections to get the half points back on things. Yes?
Speaking of tests, you have a computer, chapter 1.
I know that. We'll do that at the end of class.
Okay.
Yeah, you should have that with you. Okay? All right, now we're going to look at Chapter 3 a little bit for the amount of time we have left. All right, now I've already talked about this. I actually had made some examples, but we've already talked about that, so I can skip that part on this thing. Okay? All right, now. All right, this next section has to do with what you're going to be doing in Chapter 3. Okay? Now, here's what's important. Y equals mx plus b. This is called slope-intercept form. All right, on slope-intercept form, my question to you is, how do you graph it? Okay? You should already know this. This was Algebra 1, and it's important that you know. A lot of your testing, even college entrance testing, is going to be using this skill. All right, what you do is when it's in this form, the first thing you do is put a dot where that is. When x is 0, the range y will be that number. So when x is 0, y is going to be this number. Okay? So I'm just going to pretend that that's a 6. Therefore, I'm going to go up here and I'm going to put a dot on 0, 6. That happens to be the y-intercept. Now, what's the slope? 1/2. You should know that the top number is the y direction, the bottom number is the x direction. So this is up 1 over 2. Or it's down 1, back 2. Because -1 divided by -2 is also positive 1/2. Now, those three lines make a define a straight line, which helps me make sure I didn't make a mistake. If I only had 2 and I counted wrong, then I would have the possibility that my graph was incorrect because of a silly error. But if I do 2 dots so that I get a total of 3, then if they don't line up in a straight line, then I've counted wrong someplace. All right, so that's a little bit of insurance. All right, so that's that part. Now, this last one down here says -3x plus 1. All right, so where do I start? Where do I start? I start on the intercept. The intercept is 1. So I start here. Now, how do you do a slope of -3? It's down 3, 1, 2, 3, and over 1. Or it's up 3, 1, 2, 3, and back 1. Because 3 over -1 is also -3. Right? This is -3 over 1, which is -3. So from this intercept, that's how the line is graphed. Okay, now, that's a review from last year. You should remember that by now. Okay? Question? No? Everybody happy? All right, you got it. Okay, so now what we're going to do, we're going to add some stuff to this. Because we're in Algebra 2, we're not in Algebra 1. All right. Okay, now, this didn't come out as clear as I thought it would. Okay, right. Okay, so here's what we're going to talk about. All right, we have slope-intercept form. All right, slope-intercept form is y equals mx plus b. All right, there's a thing that's called slope point. All right, and on slope point, you have y minus the y point is equal to m times x minus the x point. And both of these are negative, and this is the slope. So this has to be distributed into this binomial, right? And when these are negative, this is the value of the point. The y goes with the y and the x goes with the x. Okay? So, suppose my point is 1, 2. The 1 goes here, and the 2 goes there. Okay? And then you can use algebra to change that. And that's what I want to show you. Okay? Because we don't graph from this all the time, although we could. Right? So this is a slope of 3, 5, and the point is 1, 2. Right? Let's go back. All right, where's the point 1, 2? The point 1, 2 is right here. Now, if the slope is 3 over 5, it's up 3, 1, 2, 3, and over 1, 2, 3, 4, 5. Or it's down 1, 2, 3, and back 1, 2, 3, 4, 5. All right, and then I draw my line through that. So from the slope point, instead of this being on the axis, this is wherever it is. But the slope from this point is counted exactly like the slope if it were a y-intercept point. Right? So if I have slope point as a given equation, I can graph it fairly quickly. Only instead of being on the axis, I'm wherever that point is to start. And then I count from this point instead of counting from the y-axis. Okay? All right, so that part's fairly easy. Now, all right, standard form. Standard form is the form for Algebra 2 and above. All right, standard form is very simply ax plus by equals c. Now, this is always positive, or supposed to be positive. Some teachers don't make it positive, but technically that's supposed to be positive. B is whatever it is, and C is whatever it is. Okay? Now, the x and the y are on the same side. Now, what happens if I give you an equation where the x and y are on different sides? You got to get them on the same side by adding and subtracting. Now, what I teach is, because the a is supposed to be positive, I look at the x value. If the x is positive, that anchors and the y has to come over where the x is. If the x is negative, then I move it to the other side using adding, so that the a value becomes positive on the other side. Okay, does that make sense? All right, so when to get it in standard form, you look at the x term first. If it's positive, it stays there and the y comes and meets it. If x is negative, then send it to the other side where the y is. All right, and then the c has to always be on the side that is not where the x and the y are. So sometimes the c moves and sometimes the c does not move. Okay? All right, so now let's see if we can sort of do that. Okay? Now, two things. All right? Here's my point slope equation. Okay? Now, one of the things that you have to do is a lot of times you have to clear a fraction. How do I clear that 5? Oops. Guess what? When I made this, I didn't change this. Hang on. You're going to have to hurt. Okay? How do I get rid of that 5? Multiply every term by 5. When I multiply this by 5, I get 5y. When I multiply this by 5, I get negative 10. When I multiply this by 5, the 5's cancel, and I multiply 3 times both of those. 3 times x is 3x, 3 times negative 1 is negative 3. Okay? Now I have this. All right? To change this to standard form. Okay, look at the x. Is the x positive? Yes, therefore the x stays on that side. This has to come over here. How do I move it? Subtract. So I'm going to end up with 3x minus 5y. 3x minus 5y. Now, the 3 is on the wrong side. It has to go the other side. How do I move it? Add. All right. I add the 3 to the negative 10 and end up with negative 7. Now, if I had slope intercept, this number would not be here, but the other skills would be exactly the same. Okay? All right, now, so let's look at another one. All right, my point is 6, 3, my slope is 2 over 5. If I graph it, I go to 6, 3, and put a dot, and then what am I going to do? I'm going to go up 2 over 5, down 2, and back 5. And so I'm going to have a slope again that's going to be like this. All right, now, y equals mx plus b. Y equals mx plus b. What's my y? 3. What's my x? 6. So now I have 12, 3, and 5. But I got to clear the 5. 5 goes over here to be 15. What I do is I see this. This is 12 over 5, right? 3 is 15 over 5. Right? Because what's 15 divided by 5? Alright, well if this is 12 and I need to add something to get to 15, I must have added 3. Because I like to work with fractions. Okay? Alright, if not, then you clear this and have 15 equals 12 plus 5b. Subtract the 12, that becomes 3, divide by 5, and you still end up with 3 over 5. Okay? Alright? So, alright, that's that part. So this is what you're going to be doing in the chapter. That's the reason I'm trying to introduce it. Alright, now let's move on a little bit. Let's try this one. Alright. If I take this and clear the 5, 5 times y is 5y. 5 times negative 3, negative 15. Then I have a 2 left. 2 times x is 2x. 2 times negative 6 is negative 12. Now, is the x positive? Yes. Then what do? That stays there and this comes over. How do I move it? Subtract. 2x minus 5y. Alright, this 12 is on the wrong side. It needs to get over here with the 15. How do I move it? Add 12. That makes this negative 3. That's standard form. Okay? Like simplifying fractions, this is how you simplify equations. If it's a linear equation, it has to be in standard form. Okay? How much time we got? Looks like we got... It's 4 after, so we got 10 more minutes, right?
It's 5 minutes.
Okay, so we got 5 minutes.
Yeah.
Okay, now, all right, my point is 3, negative 4. My slope is 7 over 2. So the 3 is the x, the negative 4 is the y. All right, in order to be able to do this, what do I have to do? I got to get rid of the 2. What's 2 times negative 4? Negative 8 equals 21 plus 2b. Alright? Negative 8 minus 21 is 29, but then when I divide by 2, so it is 29 over 2. Alright, now, so that would be y, this is the y-intercept, 29 over 2. It's not a point that's on the line, it's in between 2 lines. Alright, so, if we take y equals 7/8 2 minus this, what happens when I clear this 2? That becomes 2y, and that leaves me 7x, and this is 7x minus 29. 7x, negative 2y, 29. So that they're going to relate. So if you started with this, you're still going to end up with this. Alright, but I started with this one. Alright, 2x plus 8, because I multiplied all of this by 2, equals 7x minus 21. Now, again, the x is positive, so this comes over as a negative. Alright, now I want to try to get one that's the opposite way, because it's sweet. Here's one right there. So, if my point is y minus 6 equals negative 1/4 times negative 2 plus b. Right? I can find the b to be 22 over 4. Okay. So I'm going to put that back in here just to speed this up. All right, plus now this is x. Alright, now, notice now you're going to have a negative 1x. Alright, what's going to happen here? You're going to have 4y minus 24 is negative 1x And this one I've already changed, so let me take it back. I have to leave that there. So when this changes, that comes off. So now it's negative 22. Now, in this case, I have the negative x. The x is supposed to be positive. How do I make this positive? Send it to the other side. So when I do that, I end up with x plus 4y. And I'm done as soon as I move the 24 to the other side. And I add 24, and that 24 minus 2 will end up being 22. Okay? So if the x is negative, because the slope is negative, you only have to move one variable term. Okay, now, I've gone over this pretty quickly, but I hope that you begin to see that the standard form is these things transformed to get the two variables side by side, and the numbers and the signs, the only thing you're worried about is that the x value is supposed to be positive. Now, I've seen one book, one math book, where they did not follow that rule. Forrester is not one of those. Okay, all right. So he does it right, and all it does is just one more rule that you have to follow to get in final form. Are you allowed to leave 12 over 4 as a fraction? Yes, as long as you don't call it final form.
Oh, okay.
All right. But in final form, that's wrong. Because there's something else you can do, right? The same thing is true with equations. Standard form equation is supposed to start with a positive value of a. Okay. Now, hopefully, that'll get us caught up,
Yes.
and you should be able to rock through. So I have a test to be able to give you, and also you need to be able to pass in your quiz from 2 weeks ago that you were supposed to bring in last week when we didn't have class. Okay, so you'll get your test out. I will give you a tray. Okay? Good day today. Whoa, look at them.